So far, we have talked about the charts for qualitative variables. In this module, we're going to look at different charts for quantitative variables. For quantitative variables, especially with the continuous variables, but we can also do it for discrete variables. We tend to use different types of graphs, which is frequency histogram, frequency polygon, frequency curve, and stem and leaf plot. All these plots help us to visualize the distribution of our variable. Let's use this continuous variable that we have already talked about this data that's about the ages of the respondents in a study that was conducted by Gold et al. And they studied effectiveness on smoking cessation. So we have this continuous variable given in our data. To summarize this data, one way is to construct a frequency distribution that we already have constructed in the previous modules. From here, we can also visualize this frequency distribution by drawing a frequency histogram, where frequency histogram is also a kind of a bar chart, where one of the difference in histogram and other bar charts we have discussed so far is that over there, among the categories of a variable on our axis, the bars are separate from each other. But in a histogram, all the bars are going to join together. So let's try to construct a frequency histogram for the data we are being given. For the construction of histogram, on the x-axis, we do need class boundaries. Class boundaries are represented by, I'm denoting it by CB, class boundaries. We start with the minimum class boundary, which is 29.5. Though this is 0, we'll start at 29.5 and it goes on to 39.5 and it goes on to 49.5. We want to make sure that all these points should be equidistant from each other. It's 69.5 and the last observation is 79.5. I'll try to make them equidistant though. On the y-axis, we will have a variable frequency, which are represented by small f. So frequencies goes from 1 all the way up till 70. So I'm going to make the gap of 10. So the very first bar in our histogram is having the frequency 11, which is for the class boundary 29.5 to 39.5. So the first frequency is 11, so 11 should be somewhere here. So we construct a bar from 29.5 to 39.5, and similarly, we'll keep constructing for the other class boundaries. We want to make sure these bars share the same border. So for the next class, 39.5 to 49.5, it is 46. 46 will be somewhere over here. And in the same way, we'll keep on drawing it for the rest of our data. So next is 45. It goes somewhere here. And the last, it's 16. 16 goes here. And the last value is 89.5. So from 79.5 to 89.5, it's only 1. This is a histogram, and this is a way we construct a histogram where our x-axis represent the class boundaries and our y-axis represent the frequencies. This is a computer-generated frequency histogram, which looks much nicer than what I've just drawn. These frequency histograms can also be drawn for the discrete variables. We already have talked about the number of surgeries in our previous modules, where number of surgeries is going to be a discrete variable. To construct a frequency histogram for discrete variable, we take number of surgeries on x-axis and the frequencies on the y-axis, where we have 1 surgery, 2 surgery, 3 surgery, 4 and 5 surgeries. And the counts goes from 3 and 4 for all. So we can do it 1, 2, 3, 4. Hence, the first bar will be drawn like for the 1 surgery, we have 3 frequencies. So 3 people have got only 1 surgery in our response. So we will extend this to the halfway here. And this way, we'll keep constructing the bars for this discrete variable. For 4 respondents had 2 surgeries. So we'll keep extending it this way. Next, for 3 surgeries, we again have 4 respondents. For 4 surgeries, we have 3 respondents. For 5 surgeries, we have 4 respondents again. Over here, we also want to make sure that all these bars are of same width. Though I've tried it, but over here, for this bar, it's a bit narrower. But we want to make sure in a bar charts, all these bars are of the same width. Because these bars represent the class boundaries are of equal width. In the previous slide, we can see that the frequency histogram also help us to look at the shape of the data. So the next type of chart are frequency polygons. Frequency polygons are a type of a line chart which represents the frequency distribution in the form of line chart, where we first mark the points at the class marks, and then we join all these successive class marks into with the straight lines. Frequency polygon is a closed figure where on the both sides, both ends of the frequency polygon, we extend our diagram all the way to the x-axis. It also helps to discuss the shape of our frequency distribution. For our frequency table, we have class boundaries for the age on our x-axis and the frequency on our y-axis. We can view that the mid-class marks are 34.5, 44.5, then it's 54.5, and so on. Each dot here is the number of frequency over here. So at 34.5, there are 11 respondents. At 44.5, there are approximately 46. Yeah, there are 46 respondents. And it goes on. And we join these points with the straight lines. These type of graphs are called frequency polygon. Over here, frequency polygon shows us that 54.5 is a maximum value that has a maximum frequency, and no doubt it is 70, which is the maximum frequency here, and 34.5 having frequency 11, and 74.5 having frequency almost 16. And then for 94.5 and 24.5, we do not have any value in our data. But since we talked about the frequency polygon is a closed diagram, we extend our diagram all the way to the x-axis to make it a closed diagram. Moving further, we can overlay frequency polygon onto the histograms by connecting all these dots at the mid of these bars. It also shows the similar picture right here. Frequency curve is a third type of diagram that is third type of graph which we use to represent the shape of our frequency distribution. And this is also a line chart, which is a freehand curve. It is a smoothed curve, and it also helps us to discuss the shape of our frequency distribution. For our data, we can overlay our frequency distribution over here, and it's a freehand curve. So this line is called a frequency curve, which talks about the shape of our data. Frequency histogram, frequency polygon, and frequency curve are very effective ways to visualize quantitative variables. Moreover, they play a very significant role in defining the shape of the data that we are going to talk a lot in the future. Thank you.